Hey everybody, this is Miss Strong. I teach 7th grade science at Gibbs Middle School and I am going to be running the lesson for the day. So let's get started. Okay, so first off, this is science grade level 7 and this is activity number 3 for the summer. If you need any handouts or activities that go along with this lesson for the day, you can go to the student resource tab on knoxschools.org, the website. And if you create something really cool or want to share your graphs from this activity, then you can tweet at KCS Science and share what you have been learning and working on. So let's talk about how the video will work and then we'll get into the lesson. So you can turn on closed captions if it's available. You can adjust the speed of the video if that's available. And I would recommend shortening this into clips, so pausing it when you need to. There are 3 sections to this video, a drawing and then 2 graphs. So you may want to pause at certain points to do the work and then continue on with the video. And then this is about having a scientific argument and building one is part of this lesson. So you may want to watch it with someone so you can practice and talk through how to build a scientific argument with someone in your own home. So maybe watch this with someone else. And now let's get started. So today's lesson is all about human impact on the climate. We are going to go through the standard 7 ESS 3.2, which is engaging in a scientific argument through graphing and translating data regarding human activity and the climate. So our main question, the thing we're trying to answer here, if we're going to boil down that standard, is how can we show the impact of human activity on the climate through graphing some data? And the first thing we need to do for that to work is we need to learn about the greenhouse effect, and then we need to make some graphs. We're going to do our graphs on temperature change and CO2 change specifically, and then talk a little bit about other ways you could graph. So let's start with our vocabulary for the day. So there are 3 vocabulary terms: greenhouse effect, greenhouse gases, and CFCs. These 3 terms are really vital for understanding where we're going with our graphing. So we are going to start with these terms and then get into the rest of the activity. So first thing is the greenhouse effect. The greenhouse effect is a process that occurs when special gases called greenhouse gases that float around in the Earth's atmosphere trap the sun's heat. This process is really complicated, but we are going to break it down into 4 steps, and this is the first part of the activities in your handout. So I'm going to draw one of these. I have one made. You'll see this picture, this diagram in your packet. I'm going to break it down and talk through it, and then you are going to draw your own version of this diagram. And it can be in color, it can be in pencil, it can have a little legend to describe what's going on. This is as complicated or as simple as you want to make it. It's for you to remember this process. So however you need to make that happen. So let's start with step 1 of the greenhouse effect. So step 1, the sun releases light, and this light is called shortwave radiation. That's the form light comes in. So it travels out from the sun and all the way through space until it comes in contact with the Earth's surface. Most of it will come in contact with the Earth's surface, and then step 2, that shortwave radiation will be absorbed by the Earth's surface. Then step 3, some of that shortwave radiation that was absorbed is going to be radiated back out from the Earth's surface in the form of long wave radiation. That's what's in red here. Long wave radiation is known as heat. So it's thermal energy, if you remember that term from back in the fall. So this heat energy is released back out from Earth's surface and starts to travel back through the atmosphere out to space. But you see this green layer, That is step 4. Greenhouse gases, which float around in our atmosphere, they like long wave radiation. They like this heat. So they will take it in and absorb it and keep it for themselves. So that means that quite a bit of that heat is going to be absorbed by this layer of greenhouse gases in our atmosphere. And this is part of what helps create weather systems, keep our climate and the earth warm enough for life to thrive and grow and for us to inhabit Earth. We need a certain amount of greenhouse gases in our environment for life to exist. So I want you to keep that in mind as we talk more about greenhouse gases. So there are your 4 steps. You can pause the video here or keep going if you want to and come back to the drawing, but make sure you use this diagram I have as a key and you work through your own setup of these 4 steps. All right, so let's talk about greenhouse gases. Greenhouse gases are gaseous compound molecules. They include methane, nitrous oxide, carbon dioxide, sulfur dioxide, ozone, chlorofluorocarbons, and carbon monoxide. These 7 are what make up greenhouse gases. We are going to focus on the 2 I have bolded. So that's carbon dioxide and chlorofluorocarbons. I'm going to call those CFCs from now on because that's the shortened term. So CFCs are a compound molecule and a greenhouse gas. And they're also really often an ingredient in styrofoam and an ingredient in aerosol sprays. So certain kinds of home sprays, Lysols, things like that. These 2, there's many other products, but the point is CFCs are a greenhouse gas, but they also can be toxic. So they are a great insulator, which is why they're in styrofoam, but also as styrofoam breaks down, it's not very healthy for living things to consume. So that's something to keep in mind. You can look for yourself at ingredients. You can look up ingredients that contain CFCs or products that contain CFCs. It's pretty interesting, the stuff you'll find. But I wanted to make sure you know that as an example of a greenhouse gas. And then we're going to talk quite a bit about carbon dioxide in the next few slides. Oh, and I have a picture of a CFC compound molecule that you'll see in the bottom right-hand corner. Okay, so human contribution to greenhouse gases. This is where things get into human impact, get into our standard. So greenhouse gases, as I've said, are necessary for our atmosphere. They keep our climate warm enough for life to exist. However, human activity, such as burning coal and other fossil fuels like gas to create power and electricity, that releases extra greenhouse gas. So when your car turns on and it starts running, it is burning gas, which releases carbon dioxide particles out into the air. And then they float out into the atmosphere. This means, so if you think about one car producing carbon dioxide, all of the millions of cars and tractor trailers and factories and electrical products, so turning on a light switch in your home, factories, all of these places are producing greenhouse gases. You can see in this infographic even the largest contributors to greenhouse gases according to the EPA. So electricity, we use it every day, all the time. Most electricity comes from burning some sort of fossil fuel. And then transportation, cars, tractor trailers, planes, all of these things also burn gas, which creates CO2. So I want you to keep that in mind. If you are pumping extra greenhouse gas out into the atmosphere, and you know because of the greenhouse effect that greenhouse gases love to take in heat and keep it, what do you think is going to happen to the overall temperature of the Earth as there are more and more greenhouse gases trapping more and more heat? So that is what we're going to investigate in 2 graphs in the next upcoming slides. So stick with me. This is graph number 1. We are going to graph how much CO2 is being measured in our atmosphere in parts per million. That's what ppm stands for. So I took readings from every 5 years between 1960 and 2010. I got this from the NOAA website. You can go on and look at the data yourself. You can download it and make your own graphs. But for right now, for today, I have just taken a short segment of that data for this set of decades, and we are going to plot it ourselves. So we're going to start at 1960, and I'm going to show you where to plot the points if you want to plot along. And then for graph number 2, you are going to plot the points yourself. So let's start at 1960. It's going to be 316 is where you're going to put your dot. 320 at 1965. 326 at 1970. 331 at 1975. 339 at 1980. 346 at 1985. 354 during 1990. 361 parts per million at 1995. 369 parts per million in 2000. 380 in 2005. And 390 in 2010. So all of this together is going to show you your points, how much measured CO2 was in our atmosphere during these specific years. So if you were to connect the dots, draw a line through all of these points you just plotted from 1960 up to 2010, you can see that the amount of CO2 in our atmosphere is increasing. It's gone from 316 up to 390. That's a pretty big jump of almost roughly 40 parts per million, which 40 parts per million is quite a bit of extra CO2 in the atmosphere. So make sure you have these points. They don't have to be perfect, but they should look very similar to the ones I have plotted, and then you can draw a line through them showing the trend upwards. So keep that in mind as we move on to graph 2. Graph 2, you are going to graph yourself, but I'm going to talk about it a little bit. So the same x-axis on the bottom as graph 1 is still there. It's the years, so the same years, 1960 to 2010. The only difference is the y-axis, the vertical axis in this graph, is the difference in temperature from the average. So these average temperatures were found over the years, and then they look to see how much different each of these years was from the norm. So in 1960, for example, the global average was slightly, barely lower than normal. It was negative 0.02. So you're going to put that just below your zero for 1960, a point. And then for 1965, just slightly lower at negative 0.11. Again, really small difference, but slightly colder year in 1965. And then you can kind of see it starts trending upwards. So you go to 0.02, 0.0, all the way up until 2010, where you're going to put a point at 0.72 on your graph. And that means that your global temperature is almost a whole degree warmer than the average temperature. So plot your points, connect their dots, and then see what that looks like as a whole graph. And then I'm going to move on to the next slide, and we're going to talk about it. So how do we use our graphs to construct a scientific argument? Remember our standard. It is engage in a scientific argument through graphing and translating data regarding human activity and the climate. So Graphs are the evidence that will support our scientific argument. That is what will make our argument scientific. We need evidence, and our evidence is that data and graphing we just made. So on this fourth bullet point, there's a question, and this is how you would set up an argument for a scientific argument specifically for human impact on the climate. So let's read the question. What can we conclude about human impact on the climate based on the data and graphs we made? 1. According to graph 1, from 1960 to 2010, the amount of CO2 in the atmosphere is increasing. I bolded and underlined according to graph 1 because you always want to cite where your evidence is coming from. You want to be able to pull out your graph and show someone you're talking to, look, this is where CO2 level was in 1960, and here is where CO2 level is in 2010. That will make a huge difference when you are talking to someone or having a scientific argument. You have data, you have evidence to back up what you are saying. And then for the second one, for graph 2, according to graph 2, from 1960 to 2010, the difference in the average yearly temperature is overall increasing. There were moments when it dipped lower. You went negative 0.02 to negative 0.11, but then it started increasing. So if you look between 1960 and 2010, you can connect your dots and you can see overall, it's still increasing. The yearly temperature on average is higher than normal. Both of these sentences are great ways to show you have a scientific argument. You have evidence and data to back up what you are saying. And that is what science is all about. You need data. You need a way to show people that what you're talking about is true, that you have evidence to show that what you're saying is, in fact, really happening. So next time you are trying to understand something that's going on in science, if you see an article, you want to look for evidence. You want to look and see, where is this data coming from? What kind of graph can I see that shows this data? Does this graph that they're using actually back up what they're saying? So these are really important concepts to have. They're really important in future science classes. And as you answer the rest of the questions in this activity, reference back to this. According to what, when you are answering your questions for this activity. The discussion questions are how we are going to end this. So this is just CO2 and just temperature. There are methane, all the other greenhouse gases, CFCs, that can be looked into. These are the two we are doing for today. And the last thing I'll say is that I pulled this data from NOAA and from NASA and from the EPA. So make sure your sources where you're looking at data are really sound. I chose organizations that are nationally and internationally known and trusted. So make sure when you're looking for data and forming a scientific argument that you trust and know where your data is coming from. Okay, well, we will go to the last slide. If you have a cool drawing or a great graph you want to show us, tweet it at KCS Science and let us know what your scientific argument is for human impact on the climate, and have a good day. Goodbye.